over number 50 from the homework?
Which section or page or?
It's 4.5, page 434.
Okay, so let's take a look. Let me open here. I did not write solutions, as you know, yet. I will after class tonight. Not because I'm lazy, it's because I'm trying to keep up with grading and everything. Okay, so you said a page, you did say it, so it's in 4.5. I have the book right here. So, okay, page 435, 434 or 435. Good. So let's take a look. So you said problem 50, which is this one, I'm assuming, right? So the integral from 0 to 4 from dt over 1 plus t. Perfect. Good. So again, the focus is right here. I'm going to say let u be 1 plus t. Very nice. du equals dt. So I can change this into du over u. Careful now. When the lower limit for t is when the lower limit for t is 0, then I get 1. When the upper limit for t is 4, then I get 5. So the limits of integration, not LIM, right? The limits of integration, 1 through 5. So this is natural log of absolute value of u from 1 to 5, which changes into natural log 5. I should write minus natural log 1, but that is 0. So this is the final answer, and you don't have to go back. Of course, it's a definite integral. Good. Other questions? Is that?
I have a quick question.
Yes?
I wrote, like, probably shouldn't have, but for that answer, I wrote, like, the approximately and then, like, what the decimal was. Do you want to?
That's fine. So that's fine. It's the exact. And the approximation is whatever.
Okay.
Good. Is this okay?
Yes, it helps so much. Thank you.
Very good. What was the hang up? What was the problem here that I'm learning from you? So this is not, I'm only pointing out something that I may have not said in class. So that's when you teach me. So what do you think was the issue here? Something that I didn't say or didn't present? Naja? You may be muted or something. Am I muted?
I have a question.
Yes.
Could we go over 80?
Yes. Is it from the same page or?
It's on the next page.
On the next page, and you said number, which one?
80.
Yes.
It's also from the homework.
Okay, very good. It's fine. I will direct you here, so that's okay. So we have d of t equals 33.3 e to negative 0.5 t. Okay, so that's a divorce rate in Texas. Okay. So this is number per 1,000 people. T years after 2010. T equals 0 represents 2010. I have to remember this, right? Find the total number of divorces per 1,000 people in Texas from, okay. So total number will be the integral from, because 2010 represents 0, to 2015, which represents 5, from this, from d of t dt. And then estimate the total number. Okay, so the second one is also total number between the one from 2015, which is 5, to 10, from d of t dt. Do you want me to do both, or you want to choose one?
If you just do one, that'll, you know.
You want the first one or the second one? It's up to you.
I mean, probably the first one, because it's just simple.
Okay.
There's a 0 there, so.
Thank you very much. I really appreciate it. So I have 33.3, the integral from 0 to 5, e to negative 0.5t dt. And a long time ago, we also discussed this and we had an example. You don't really have to use a substitution for this because we know that it's e to negative 0.5t over negative 0.5 from 0 to 5. How do I know? Because when I differentiate this, I will have a negative 0.5 that will go away with this, so then I get that. So now I have to plug in 5 and subtract when I plug in 0. So I have then negative 33.3 over 0.5. You know, I don't want to even look at constants. So when I plug in 5, I have negative, oh, I don't have any negative in there. When I plug in 5, I have negative 2.5 when I multiply these two with 5 in here. And then minus when I plug in 0, but I get 1. So now I need, in this case, I need to approximate because I can't give the answer as is. So I will approximate. I'm going here. Let's clear everything. So we had negative 33.3. I don't like that. In parentheses, negative 33.3 divided by 0.5, and close and open again, e to negative 2.5, and then completely outside minus 1, and this is per 1,000 people. Total number, the question was find the total number of divorces per 1,000 people. So the answer is 61 per 1,000 people. So 61 divorces per 1,000 people. Good, very good question. Is there anything else before we practice consumer and producer surplus? Did you come across
I have
anything?
a question.
Yes?
Would the second one, like B, is B also gonna be like -1?
So everything is the same, but it will be from 5 to 10.
Okay.
So for the second one,
Okay.
so we have 33.3. I just want to write the integral so we can all see it. From e to negative 0.5t dt. And now all I have to do is just copy all this, basically copy all this as negative 33.3 divided by 0.5. And I will have, when I plug in 10 at the top, so I have e to negative 5 and minus e to the fifth, so minus 2.5. Good. So then I can share. Okay. So I will copy what I had. That's how lazy people work. And I will put here -5, unless I mess it up by who knows what I'm doing here. Something, okay? And then E, and that power is -2.5. And we get 5 per 1,000. So I still had -33.5. Let me just check here. It was -5, right? So from 5, see, I still did something. So so when I plugged in, oh, no, I don't know, it was okay. When I plugged in 10, yes, it was
Yeah, I
negative.
got 5 too. So
Okay, good. So I just wanted to make sure that I did. Good, excellent, perfect. I don't have to check then. If you guys got the same thing, I'm fine.
I had a question
Sure.
actually about this. One of them, like, why does it say estimate, and then one of them, like, when you're gonna estimate it anyhow?
So you're asking about the question. The question says find. It doesn't say estimate. Find the total number of divorces per 1,000. Oh, and the other one, estimate the total number of divorces in Texas between 2015 and 2020. Because one possible answer here is t equals 0 is for 2010, and 2010 to 2015 may use the same function d of t. But once we go from 2015 to 2020, we don't know if d of t is still valid. We are now going too far out from t equals 0.
Okay.
So I see your point. It's a brilliant point. So in part A, indeed, it says find. In part B, it says estimate because it's a little bit further away from 2015 to 2020. For the next 5 years, maybe the function is valid. But for the next 10 years, we don't know if they have to tell us, is the function still valid? If it is, then they will say find. It's a very good point. Thank you for pointing that out. Very good. Well, obviously everyone studied for today. I'm so happy. Good. Other questions? Is there anything else before we go to applications from 5.1, page 480? You can always stop me if you remember something. Okay, so let's choose any problem you want. It can be fictitious, or it can be a word problem. They're all the same. We are going to look at the equilibrium point or any other point they give us to find the consumer surplus and the producer surplus. So it can be a fictitious example for practice, or we can directly go to applying in word problems.
You can choose.
You one each.
Okay, so let's start with 15 then. In 15 we have skydiving. I've never tried it. Maybe you did. And is willing to pay P dollars per jump for, okay, so the demand, which is price per unit. Let me put it here, dollars per unit. That's the demand. I mean, that's the Y variable. And remember, the X variable is number of units. Okay, so this is 7.5x squared minus 60.5x plus 254. Find Beth consumer surplus if she makes 2 jumps. Aha. So I don't really care how this function looks like, but I know it has a minimum. I don't know exactly where the minimum is, so I'm going to graph it for now. I'm going to graph it like this. Okay, so we are told, so this is units, and this is dollar per unit. So, okay, so she makes 2 jumps, and again, they're asking us to find how much extra she's getting for those 2 jumps. Okay, so find consumer surplus if she makes 2 jumps. I'm going to plug in 2. This is X is number of jumps. I'm going to plug in 2 to see how much she's paying per jump. So right here, D of 2 is the number of the dollars per jump when she jumps twice. So dollars per jump. Okay, so let's see what that is. D of 2, 7.5 multiplied by 4 minus 60.5 multiplied by 2 and plus 254. So let's see how much she's paying, and then we'll see what is her surplus. Okay, you know me. I like the function in there. 7.5, we may need it, we may not, that's okay. Minus 60.5x and plus 254. I like it like that, and then I plug in 2. So when I plug in 2, she is paying, steep, $163 per jump. So this is here, 163. This is what she really pays. She pays 2 jumps multiplied by 163. And what is that? 6, 2, and 3. So she's paying a total of this area that is 326. Now, we want to determine this area. This is what she's getting as the consumer surplus. And remember how easy it is to find this area. We will find this total area under the graph of d of x, and we will subtract this area, which is 326. So for 2 jumps, so the consumer surplus, if you want, for 2 jumps is the integral from 0 to 2, as we did in chapter 4, from 7.5x squared minus 60.5x plus 254, of course, dx, mandatory, minus this area. Okay? Any questions? Now, I'm going to try to save some time because I would like to finish the material this week, and we have to. So I'm going to put this in the graphing calculator and not show any work just because I want us to finish. Okay? I would never do that otherwise. So I'm going to use this feature that I'm not really fond of, but just to get the number. So from 0 to 2, and I have 7.5x squared, and then minus 60, oops, no, minus 60.5x, and plus 254. Of course, I don't understand why they make us put the x, because I can't put anything else in there, can I? Okay, never mind, minus 326. Enter. 81. So that is her surplus. Because she's buying 2 jumps, the price is a little bit lower. So she's basically, nobody's giving her in her hand 81, but she's saving 81. Or you can say she's getting a little bit extra. How much extra in dollars? 81. Good. So that was for particular 2 jumps that they wanted us to look at. Fine. Now, suppose a supply function, okay, now they're giving us the supply function as s of x, which is 15x plus 95. And they're asking us to find the producer surplus if they sell her 2 jumps. That's how much more we are paying and they make extra, if you want. Okay, so the same idea. So the producer surplus for 2 jumps, exactly, is the 326. Oh, quick, careful. So this is the producer surplus. I mean the supply function, and here is the 2. And here I have to determine what is S of X, number of dollars per unit. I did not determine it, so I have to plug in 2. So S of 2 equals, that's easy, 30 plus 95, which is 125. So this is 125. So what are they getting? They're getting 2 times 125, which is 250. So careful, 250, in order to determine this piece now, 250 minus the integral from 0 to 2 from 15x plus 95 dx. And I squeeze it in here. I'm going to write it again. So produces surplus for 2 jumps is 250 minus the integral from 0 to 2, 15x plus 95 dx. So let's see their extra.